Good morning all of you. So first already in second VUC along with the theory topics we completed a coaching also. We have to revise the first year topics from starting onwards. See carefully, the one by one we will see is nothing but the first topic we can see is nothing but some basic concepts of chemistry. Some basic concepts of a chemistry. One or two classes we will see the synopsis, then we can go for objective, you can get easily. Okay. We will get it. See carefully, is nothing but some basic concepts of chemistry. See, what is the basic concepts of chemistry means? Okay, so first of all, here we have laws of chemical combination. One by one we will see at least one or two classes, you will get the clarity, then we can go for objective, we can get very easily. See, a laws of chemical combination. Laws of chemical combinations. So what laws we have, what they are telling, all these we will discuss. Under this, the first one is nothing but law of conservation of mass or energy. Law of conservation of mass or energy. See who invented this statement. This is invented by Lavoisier. And what he told. So you know very well, in any process energy or mass neither be created nor be destroyed, but we can transfer from one form to another form. If you can apply the same concept for the chemical balanced reaction, there what is the concept? Weights of reactants is equals to weights of the products. Means the reactant will be converting into products, but there is no excess or there is no improvement in the quantity of the reactants or decrement in the quantity of the reactant, just the form will be changing. That's calling as law of conservation of mass or energy. Just I will tell you one or two example. You take C plus O2 gives rise to CO2. You know it is a 1 mole of carbon, nothing but 12 grams of carbon. 1 mole of oxygen, 2 16s are 32 grams. Together how much we are getting? 44 grams of reactants we have, and those all reactant will be converting into 44 grams of the CO2. Is there any change in the quantity of the reactants and products? No, as usual. But carbon changed into carbon dioxide, oxygen changed into carbon dioxide. Means 12 plus 32, it is also nothing but 44 grams of CO2. I will tell you one more example. 2H2 plus O2 gives rise to 2H2O. 2H2, 2 2s are, yes, each hydrogen is 1, 4 1s are 4 grams plus 2 16s are 32 grams. Together we are getting 36 grams of the reactant we have. And each water molecule how much? 18. 2 16, 2 18s are 36 grams. Means how much reactants you are taking, same amount of the products we are getting, but hydrogen changed into water, oxygen is also changed into water. The form will be changing but quantity no changes. How much you are taking, that much only will be appears, but a chemical or physical form will be changing. You can see some other laws is nothing but law of definite proportion. Law of definite proportion. See what is the meaning of law of definite proportion? Who invented? This is invented by Prof. What he is telling is a definite, is a fixed. So means if you take any chemical substance at any time, at anywhere, the components or the constant particle weight ratio should be fixed. Means in a particular chemical substance, always the constant particle weight ratio will be definite or fixed or constant. What is the meaning of this one? For example, you have water. Yes, in that water we have 2 hydrogens and 1 oxygen will be there. Weight ratio has to be taken. 2 ones are 2 is 2, 1 16s are 16 is nothing but 1 is to 8. Wherever, whenever you take water, in that hydrogen and oxygen weight ratio will be 1 is to 8. It will be fixed for water. And I will tell you one more thing. You take carbon dioxide whenever and wherever. In that we have 1 carbon and 2 oxygens will be there. Yes, 1 carbon 2 oxygen means 12 atomic weight and 2 16s are 32. We have 3 is to 8. Means wherever, whenever you take CO2, in that carbon and oxygen weight ratio should be definite, 3 is to 8. And we are going for one more, is nothing but law of multiple proportion. Law of multiple proportions. The concept you have to understand very carefully, then the objective is nothing for you. Law of multiple proportion is invented by John Dalton. So what is this concept? What is telling? Okay, it's the statement I will tell you first. When 2 different elements combine together, we are getting more than one type of the product. In that, one of the element will be having fixed quantity combining with other element in the simple ratio by their weights. Yes, you can't understand how many times you read it, just I will tell you. For example, you have carbon plus oxygen, we are getting carbon dioxide. I will take same carbon and half oxygen, we are getting CO, we are getting. Carbon and oxygen combined together, one is CO2, another one is CO. Here, which is a constant, carbon quantity is constant because 1 mole, 1 mole. How much it is indirectly? 12 grams. Combining with 32 grams of oxygen. And here also 12 grams is combining with the half O2. Half O2 means single oxygen. Single oxygen means 16 grams. When 2 different elements combine together, then you are getting more than one type of the product. In that, one of the element with fixed quantity combining with other element in the simple ratio. This one and this one has to be considered. What is the ratio of oxygen? 32 is to 16 is nothing but 2 is to 1. Can I tell you one more thing? For example, you take another example, nitrogen plus oxygen. We are getting 2NO, we are getting nitric oxide. Not like that, nitrogen combining with half O2, we are getting laughing gas, nitrous oxide. Okay, now fixed quantity is what? Nitrogen is fixed quantity because 1 mole of nitrogen, 1 mole of nitrogen. Here how much? 32 grams. But here each oxygen 16 grams. What is the weight ratio here? 32 is to 16 means is nothing but 2 is to 1 ratio we are getting. So means when 2 elements combine together, you may get more than one type of the product. In that, one element will be having fixed quantity combining with other element in the simple ratio by their weight. That is proposed by John Dalton, called as multiple proportion. Now I will tell you some other statement. You see carefully, is nothing but 4th one, law of gaseous volumes. Law of gaseous volumes. Law of gaseous volumes is invented by Gay-Lussac. This is also calling as a Gay-Lussac law. Okay, in that name answer is there. This is applicable for the gaseous reaction. Same statement for gaseous reaction. What is this one? In case of gaseous chemical reaction, always chemicals combine in the simple ratio by their volumes. Means, for example, you take nitrogen combining with hydrogen, we are getting 2NH3. Sir, what is the meaning of this one? Whatever coefficient is there, that only represent moles or its volumes, is nothing but 1 volume of nitrogen combining with 3 volumes of hydrogen, we are getting 2 volumes of ammonia. What is the meaning of this one? For example, You are taking 1 liter of nitrogen, compulsory requires 3 liters of hydrogen and gives 2 liters of ammonia. That is the meaning. The ratio will be fixed. I will tell you one more thing. For example, 2SO2 plus O2 gives rise to 2SO3 will be there. So what are the gaseous volume? All are in gaseous phase. Now 2 volumes of sulfur dioxide combining with 1 volume of oxygen gives 2 volumes of sulfur dioxide. Means, for example, 2 ml of sulfur dioxide sufficiently combining with 1 ml then gives 2 ml of sulfur trioxide. That's a statement. All of you understanding? Yes, it's a very important thing. Now we are going to one more law, is nothing but Avogadro's law. Avogadro's law. So what is the Avogadro's law? So under same conditions of temperature and pressure, means we have to take this room as the our atmosphere. So under same temperature and pressure, equal volumes, this is important statement, equal volumes of all gases having same number of moles or molecules. What is the meaning of this one? For example, you are maintaining room condition 25 degrees Celsius temperature and 1 atmospheric pressure. At this room condition, I am taking 1 liter of hydrogen gas. I am taking 1 liter of oxygen gas. I am taking same temperature and pressure and same volume. Then whatever gas, nothing, containing number of moles of hydrogen is equals to number of moles of the oxygen. Very important statement for competitive also. Under similar conditions of temperature and pressure, equal volumes of all gases containing same number of moles or molecules or equal number of moles or molecules. So from this what we can tell, just you see carefully. For example, you have 1 liter of hydrogen containing n number of moles of hydrogen. I am taking 2 liters of hydrogen. I am taking. What may happens? Volume of gas increasing. Automatically what happening? Number of moles or molecule is increasing. We are getting 2n number of hydrogens we are getting. So as the volume is increasing, number of moles or molecules is also increasing. That's why volume of gas is directly proportional to number of moles or molecule under same temperature and pressure condition. You are increasing the quantity of the gas, the number of moles of molecules will be going on increasing. Sir, here concept is, what is the meaning of N? N means is nothing but number of moles. How can you find out the number of moles for the chemical substance? Is nothing but weight of the substance by gram molecular weight of the substance. This is important. For example, you have 6 grams of hydrogen. Sir, what is the meaning of 6 grams of hydrogen? Nothing but number of moles of hydrogen is equals to weight of the substance by molecular weight of the substance 2 is nothing but 3 moles. I will tell you one more thing. For example, 64 grams of oxygen. Number of moles of oxygen is equals to weight of the substance by molecular weight of the substance. 2 16s are 32 grams. Nothing but 2 moles of oxygen gas. So very important, under same conditions of temperature and pressure, equal volumes of all gases containing equal number of moles. As the volume of the gas is increasing, the number of moles and molecules is also going on increasing. It's a very important statement. And sometimes he is asking this one, a reciprocal law. Reciprocal law. So what is the reciprocal law? Is invented by Richer, R-I-T-C-H-E-R, Richer. So what it is saying? Just I will tell you one example, then you can understand the statement. For example, you have hydrogen and oxygen and sulfur. If you take the 2 different elements combining with the fixed quantity of the sulfur, for example, by this combination we are getting which one? Hydrogen sulfide. The quantity of the sulfur will be remain same amount, then what you may get sulfur dioxide we are getting H2S and SO2. Okay, now when two element will be combining with third element with fixed quantity, in this what is the weight ratio of these two elements? Hydrogen is to oxygen. How many hydrogens? 2 hydrogen, 2 ones are 2, 2 16s are 32. Nothing but what you are getting? 1 is to 16 we are getting. Now when these two elements are directly combining together, what we are getting? Water we are getting. So in water, what is the hydrogen ratio and oxygen ratio? 2 is to 16 is nothing but 1 is to 8. What he is telling? So separately weight ratio is nothing but how much? 1 by 16 by is nothing but 1 by 8 is nothing but 8 by 16 is nothing but 1 by 2. This is only calling as reciprocal law. What is the law? I will tell you. The weight ratio of the two element which will be combining with fixed quantity of the third element is always simple ratio by the weights of two elements when they are directly combined together. Once again, when two elements, the weight ratio of the two different element combining with fixed quantity of the other element is always the simple weight ratio by the element which they directly combine together. So this ratio and this ratio should be simplest ratio, that is only reciprocal law. Just I will tell you one more example. Copper is there and we are taking sulfur and oxygen and copper. Sulfur and copper combination is nothing but copper sulfide. Copper and this one is nothing but CuO. Here which is the fixed quantity? Copper is the fixed quantity. Then what is the weight ratio of the sulfur and oxygen when they combining with fixed quantity of the copper? Sulfur is to oxygen is nothing but 32 is to 16 is nothing but 2 is to 1. Okay, when these two are directly combined together, what you are getting? Sulfur dioxide. In this sulfur dioxide, sulfur and oxygen ratio, 1 sulfur 32 is to 32 is nothing but 1 is to 1. And we have to take this ratio and this ratio is in simplest ratio. Means take 2 by 1 by 1 by 1, finally 2 by 1 is the simplest ratio. That's why this is calling as a reciprocal law. The weight ratio of the two element which is combining with fixed quantity of the third element is simplest ratio of the weights of the two element they are directly combining together. So that's calling as a reciprocal law. Now we are going to discuss some other things. So loss will be over. See carefully the what we are teaching, just once revise the things. You can go through the objective. Well, next class I will upload the objective bits and we can go through that one. We can get it. Listen carefully. Some other things here is nothing but dimensional analysis. Dimensional analysis. What is the meaning of dimensional analysis? The given measured value converted from one system to another system, means CGS to MKs or liters into milliliters or kgs into grams, like that, converting a system or measured value from one system to another system. Okay, while here some important conversions is there. 1 inch. 1 inch is equals to 2.54 centimeters. Yes, if you know, it may help us. And if you can take 1 dm cube, decimeter cube is equals to 1 liter is equals to 1000 ml, whatever it is, same meaning. If you want to convert degree Celsius into degree Fahrenheit, degree Fahrenheit is equals to 9 by 5 degrees Celsius plus 32. For example, he given 20 degrees Celsius is equals to how many degrees Fahrenheit? Question. Substitute here, degrees Fahrenheit is equals to 9 by 5 into 20 plus 32. How many times? 4 times. 4 9s are 36 plus 32 is nothing but 68 degrees Fahrenheit. Like that. This is also you may ask. And Kelvins. Degrees Celsius plus 273. This is helpful a lot. To convert degrees Celsius temperature into Kelvin scale, we should add 273. Not like that. If you want degrees Celsius, what has to be done? Kelvin minus 273 has to be done. Degrees Celsius into Kelvins means we should add, and Kelvins into degrees Celsius means minus 273 has to be done. Are you understanding? These conversions are very important. Later, we are going to some other important information, scientific notations. Scientific notation. Every topic I will touch, just revise the things and recollect the information. What is the scientific notation? Actually, in that measured values, we have so many zeros. Every time writing that all zeros will be complicated. That's why we are expressing that one in a shortcut way called as scientific notation. Generally, scientific notation means capital N into 10 to the power of small n. What is the capital N range? 1 to 9.9. And what is the small n values? Maybe positive values or negative values. For example, take 6.023 into 10 to the power of 23, already in scientific notation. Are you agreeing or no? Yes. Why? Because it is a 6.0 means 9.9 below. Not like that. For example, 21.56 into 10 to the power of 50. Is it scientific notation? No. Should make it. What I should do? I have to make it 2 point. To shift 2 point means we are shifting decimal to left side. 2.156. While shifting decimal point to left side, how many digits you shifted? 1 digit. That's why that many digits we should add in 10 powers is nothing but 10 to the power of 16. Don't forget it. And I will tell you, for example, 0.0416 into 10 to the power of 9. So now I want to make it as a 4 point because I should get 1 to 9.9. 4 point means we have to shift the decimal point to right side 2 digits. 4.16 into, while shifting decimal to right side, minus. So 2 digits means 10 to the power of 7. These are also very important things. And later we have to go for some important information is nothing but precision values. Precision values. What is the meaning of precision values? Anybody? For example, the values, whatever measured values will be there, values just close to each other. Close to each other is calling as, just I will tell you later a clarity. The values what you measured, just they are close to each other is calling as a precision values. What is the meaning of accurate values? Accurate values. Accurate values means what? The values which are close to the original value, is called as accurate value. Just close, precision. Which are close to the original value called as a accurate value. Just I will tell you. Actually, for example, I given 2 grams of a substance I given to the one student. 3 students, for example, student A, student B and student C. Student A first time reported its weight as 1.94, second time he reported as 1.95. Is it calling as a precision or accurate? Tell me. 1.94, 1.95, they are just close to each other but not close to the original value. That's why they are calling as a just precision values. No, B student did 1.99 and 2.00. Yes, they are very close to the original value. That's why they are calling as accurate values. Third student did 1.95 and 2.05. They are close to each other? No. They are close to original value? No. That's why they are not precision values and accurate values. This is important. Sometimes he is also asking like a theory question he will ask. Are you understanding? Yes, later we have to go for some other things is nothing but significant figures. Significant figures. So what is the meaning of significant figures? So significant figures means is nothing but a meaningful digits which tells about certain values and also one uncertain value. So significant figures are the meaningful digits of the measured value which tells about certain values and also one uncertain value. Sir, what is the meaning of certain and uncertain? For example, actually I given one thread I given to 3 students. They reported its length as 11.5 and 11.6 and 11.4. Okay, in these 3 measured value, 11 is the fixed amount, calling as certain digits. And whatever lost digit is there, it will be varying plus or minus 1. That's why is calling as uncertain digits. Okay, together is calling as a significant figures. Significant figures means is nothing but meaningful digits which tells are together of certain digits and also uncertain digits. So in these measured value, significant figures are 3. That is the meaning of that one. So 2 significant certain digits is there, 1 uncertain digit is there. Together is calling as a significant figures. Just I will tell you now some rules for significant is also important for the competitive point of view, like CET or Neet examination point of view. Just you see first condition, no zeros, no decimal points. First case, no zeros and no decimal point. No decimal point. All are non-zero numbers, like 1, 2, 3 is there. How many significant figures? 3 significant figures. All should be considered. Okay, now zeros are there. Zeros are there, but no decimal point is there. No decimal. Means if zeros are coming extremely left hand at 216. If extremely left hand, should not consider 3 significant figures are there, 1, 2, 3. If zeros are coming extremely right hand, also not considered. These also not considered. Then we have only 3 significant figures. Not like that, zeros are coming in the middle of the non-zero numbers, then all should be considered. If zeros are extremely left hand and zeros are extremely right hand, should not consider. If they are coming in the middle of the non-zero numbers, we have to consider them as a significant figures. Now, I will tell you one more thing. Decimal point, third case. Decimal point after 0. After 0. For example, 0.123 is there. How many significant figures? 3 significant figures are there. Not like that, 0.00216 is there. Zeros are extremely left hand, don't consider them as a significant figures. How many are there? 3 are there. Not like that, if zeros are coming 21600, coming extremely right hand, should consider them as a significant figures. Then we are getting how many significant figures? 5 significant figures we are getting. Not like that, zeros are coming in the middle of the non-zero numbers, then all should be considered as a significant figures. 5 are there. It's a very important case. Is a decimal point coming after 0, then zeros are coming extremely left hand, should not consider. If they are coming right hand side or extremely right hand side or in the middle of the non-zero numbers, has to be considered as a significant figures. Is another case, the decimal point is coming after non-zero number. Non-zero number. Yes, if non-zero number means wherever zeros are coming has to be considered. For example, 2.12. How many significant figures? 3 significant figures. No, 2.0012. How many significant figures? 5 significant figures. 6.21600. Yes, wherever coming has to be considered. Why? Because up to this one certainty, this is the uncertainty. Together we have 6 significant figures. And like that we have 6.21006. There also we have 6 significant figures. Very clear. When zeros are coming after non-zero decimal point number, all should be considered as a significant figures. So later we have to see, if suppose you have, this is important number, exact numbers is there, exact numbers is there. For example, 5 apples is there, 5 apples means exact.